Hi guys. Today in this video we are going to see how to reverse a linked list in K group. Okay. So basically we are provided with a linked list 10, 20, 30, 40, 50, 60, 70 and 80. Okay. This is our linked list and let's say the value of K is 3. So we have to reverse this linked list in K groups. That means uh, there will be a one group. The size of one group will be 3. So one group, two group, and 70 and 80 cannot be included, so we will not include them in the group and we will not reverse them, so they will remain empty. Empty means they will just appended as it is. Okay, so we have to reverse these three nodes. So 20, 30, 20 and 10, reverse these three nodes, 60, 50 and 40. After that, exactly same, 70 and 80, no need to reverse them. So we need to get the value of this head. Okay, this new head. Okay, so how we are going to do this, I don't know, but we will break this problem in subparts so that we are able to write the code. We will just visualize what are the process, what are the subparts of this problem. Okay, so my first part basically I have to get groups of K size. So this is one group, this is second group, and they will remain empty. So first thing is I have to get the groups of K size. So how I am going to get this group? So basically I will create a loop. Simply I will create a loop which will start from 0 and which will end at less than K. That means I will run this loop K number of times. So this loop will run for 10, 20, 30, and similarly for 40, 50, 60, and yeah, that's all. So this loop will work for these three nodes. So what this loop is suggesting, this loop is saying us that I have created a group. Okay, now I created this group. Now what I have to do, I have to reverse these nodes. So reverse node, what I have to do, firstly I create the group, then I will reverse this node. Okay, after that, this is the main process, this is the main part where a lot of students get confused. What is that part? Now you got 30, 20 and 10, you got this. Now what? Now you need something which is present at the head and which is present at the tail. You need something, na? Understood? How you are going to access this linked list if you are not having any node? So firstly, some node should be present at the head and some node should present at tail. Why we are requiring tail? Because the rest of this linked list should be get pointed just after this tail. So let's say this linked list is returning me something, some node. So what I have to do, I will put that node just after that tail. So this is my requirement. Firstly I will create a group, create group. So this node is creating group, this is reversing, and what this will return me, 30, 20, 10 and some node which is present at the first node and some node which is pointing the last node. These are my requirements. And again I will check, I will run this loop, run the whole procedure for these three nodes, and then I will stop. So what I said that this is my whole process. And what I am doing, I will do this process for these three nodes. After that, let's say I have completed this process for these three nodes. So these three nodes are removed. Okay, and because these three nodes are shifted here, so I removed them. Now, initially the value of length was 8. As you have seen, we are having 8 nodes. Now 3 are removed. So now length became 5. Okay, now I will do the same process for these nodes also. So what I will get 60, 50 and 40, in which some node is pointing this node and some node is pointing this node, head and tail. Okay, so these three nodes are also removed. Now I will check what is the value of length. The value of length is 2, which is lesser than K. which is lesser than k. That means if the value of length is lesser than k, then I have to stop execution. I have to stop execution and just put all the nodes after the last tail which I got. The last tail which I got. So this is the quick overview which I am going to do. This is the quick overview. Okay. Now let's move to the deep explanation. Deep explanation again. I hope you guys understood what is the quick explanation. If you are able to understand 10 to 20% of that, that's also enough for me. That's enough for me. Okay. So 10, 20, 30, 40, 50, 60, 70 and 80. This is my linked list. Now what I have to do? Basically, let me explain you the reverse function. Firstly, let me explain you the reverse function, because we will connect the path. So let's say 10, 20 and 30. So I will ask you how you will reverse a linked list. Depends on you. It depends on you. But sometimes you have to follow some procedure. You can reverse this linked list by swapping the values. That's also very easy. You can reverse this linked list using previous pointer, current, previous and forward approach. Okay, all of the approaches are fine. They will work. Definitely all of the approaches will get work. But I am going to explain you a new approach. Okay, so just cope up with me. What I'm going to do, I will basically current is here. Okay, so I will, this is my step one. I want 10. I want only node 10, which is not attached with anyone. I want only 10. Okay, so you want only 10. So if you will get access to 10, so you have to save the next pointer now, because if you will remove this, then the rest of the linked list is gone. We are not having the rest of the linked list. So firstly, I will save this. Just cope up with me what I am doing. I will save this. So first process, I will create a node which will save the next pointer of current. Okay, this is my step one. So my save is here. Now what I will do, what is my main motive? To get that node separately. So I will do current next equals to null. Understood? So the next pointer of current is null. So this is removed. The link is removed. Now I get 10 as a node. Okay, so I am having this separate node. Now my main work. Now I will pass this node to my function, which is called add first node. Okay, what this function will do? Let's take another example. I am having this linked list 10, 20, and I am passing 30 to that function. So what that function will do? That function will append this node just before my whole linked list. So head is here, tail is here. Easy. So what I have to do? I have to put this node in front of all the nodes. So 30 is here. Okay, this node is here. Now what I have to do? I will just put 30.next as head, and then I will shift the head pointer on 30. Yeah, you can see this is correct, very correct. Let me do it again. I have created, I am having a node. I know I am having node 30. So I will put 30 here. Basically 30 is here. What I will do? 30.next as head, and then I will shift my head pointer on 30. Okay, so this is what add first node function is doing. Easy. So I am having this node 10. What I will do? I will pass this 10 to my function. So that's very cool. But as I said here, I need some head and tail which is pointing that node now. So what I will do? I will create temporary head, which is initially null, which is pointing nothing, and temporary tail, which is also pointing nothing. Okay, so basically I am having two nodes which are pointing nothing. Easy. And now when I passed this 10 to my function, that function will check. Yeah, that temporary head, you are null. Temporary tail, you are also null. And I am giving you a node. You just adjust yourself. you just adjust yourself. So this node will say, okay, we got 10, we got this node. Let me remove this, and I got this node. Leave it. I got this node. Okay, this is current. So what these two pointer will do? These pointer will adjust themselves. So for a single node, head is also same, tail is also same. Okay, we have seen here. Okay, now let me remove this because we have put it 10 here, so this is removed. Now after that, what my step 3 was to pass this node to add first node function current. Okay, and I got this result. Easy. Now what I have to do? I have to shift my current to save so that I can traverse the linked list. So I will put current equals to save. These four steps are very important. What I have done lastly, I put this current on save. Okay, now again, what this process will be done k number of times, because we need the group of k peoples now. So we are requiring k peoples to get reversed. So this is the process of reversing a linked list. Understood? So now current is here, save is here. My first line, save equals to current dot next. So save will shift to the next of current. Easy. Now what I have to say, I have to separate this 20 from the linked list. So yeah, I got a separate 20 node. Now I will pass this 20 to my function. So what that function will do? That function will ask temporary head and temporary tail that I am passing you a node. You have to adjust yourself. Okay. So 20 will come here. 20 will come here. Current is pointing to 20. So 20 came. Now what I have to do? I have to place this node in front of every node. So 20 dot next equals to temporary head, and then shift this temporary head onto 20. Got it? Let's do it again. We have seen the exact thing. I'm doing exact thing which we have done here. Okay. So 20 will come. Current is pointing 20. So what 20 will do? 20 will point 10 to its next, and then temporary head will shift on 20. So this is good, very good. So this is our result from second iteration. Now current equals to save. So just current equals to save means, let me remove this, and current will be shift on save. So current initially it is here. Now current is shifted on 30. Now again this process will run because we have two iterations. We have completed two iterations. This is third iteration. Save equals to current next. So save will move to null. Now again current next equals to null, which is initially null. Now pass this 30 to this function. What this will do? This will put that 30 node here. After that 30 will get connected to temporary head, and temporary head will shift on 30. Okay, we got this. And then let me remove this, and then current equals to save. So current will move here, and this will be removed. Okay, so this is our process. This is our some process which was going behind. Okay, now what's my result for 3 k equals to 3? I got this. Some pointer is pointing the first node, some pointer is pointing last node, and I got the list in reversed order. Okay, that's very good. Let's move to here again to our linked list. 10, 20 and 30. 10, 20 and 30 basically what my main loop. I am explaining you the workflow. My main loop will run until my length is greater than equals to k. Okay, this is my main loop. I have explained you three nodes will get removed. So these three will be removed in first iteration. After that, in second iteration, these 3 nodes will get removed. And now the length is 2. So, and 2 is not greater than or equals to 3. That's why we will not iterate it again. Understood? So in every iteration, we will remove k nodes. Easy. Easy. So in first iteration, we got this. And what we got? We got 30, 20, 10, and temporary head is pointing here. temporary tail is pointing here. So basically what we got some a sub part of that linked list, okay. But what we require the whole linked list to get reversed. So to reverse the whole linked list, we should have some point now from which we can access that linked list. So let's create two more nodes, two more pointers, not nodes, pointers, which is original head, original tail, which is initially null. So what I have done, I have created two more pointers, which is original node, original head, and original tail, which will, what they will do, they will adjust themselves on the main linked list. Okay, so our final answer will be original tail is at the last and original head is at the first of our main linked list. Understood? So initially they are null. Yeah. And after first iteration, I got this. So what I have to do, what I should do, original head should point here because it is null, and original tail should point here. Okay, let's say we are having only this linked list. Only this linked list is our answer. So what you will do, you should point original head here on original tail here. Yeah, this is okay. Okay, very good. After that, our second iteration, this second iteration, what this will do, this will pick these three nodes, and it will return me what it will return. It will return me 60, 50, and 40, and temporary head is pointing here, temporary tail is pointing here. Now the first thing which I saw is that temporary head is present here also, temporary tail is present here also, and here also. Is this possible that some node is pointing 30 also and 60 also, the same node? No, na. So what we have to do, before this process, this is my first iteration and second iteration. In between these two iterations, what I have to do, before moving to second iteration, I have to make temporary head as null and temporary tail as null, so that there should be fresh start for every sub part. Fresh start. Okay, these are representing that I am going to start freshly. Understood? Now after that, I got temporary head here, temporary tail here. Oh, let me remove this. Temporary head equals to null, so this is removed. Temporary tail equals to null, so this is also removed. Okay, I got this. Now in second iteration, I got temporary head on 60, temporary tail on 40. Now what should I do? You can see now, temporary original tail should point to temporary head. Let me explain it again. What we are requiring, we require 30, 20, 10, then 10 should connected with 60, 50, 40. Okay, so 10, original tail is pointing 10, and 60 is pointed by temporary head. So we should do this. Okay, after that, what we have to do, original tail is the last node of our original linked list. This is our original linked list, 30, 20, 10, 60, 50, 40. And we can see original tail is at not its suitable position. So what we will do, we will shift our original tail to temporary tail. Why? Let me explain it again. Because original tail should be at the last, and previously 10 was the last node. That's why it was correct. After second iteration, we got this 30, 20, 10, 60, 50, 40. So now 40 is the last node, and temporary tail is pointing 40. So what we will do, we will shift original tail here. Okay, now third iteration. But in third iteration, it will check that length, the value of length. In second iteration, these three nodes are removed. Now it will check, in third iteration, it will check that the value of length is 2 and the value of k is 3. So it is lesser than value of k. So what I have to do, current is here. Okay, so current is here. Now you will say, how current is here? We don't know. So I will explain it again. 10, 20, 30, 40, 50, and 60. Okay, so you can ask me now that how you can say, how you will get current on 70. So that's what I'm explaining. you might know that, yeah, when I was explaining this, here was 10, 20 and 30. Okay, initially current was here. When I explained the reverse function, I am reminding you, okay, what we are doing. Current is here, save is here, then we moved current on this node, after that on this node, and after that we move current to null. We move current to null because we are having only three nodes. Only because we are having only three nodes. So you can examine the exact criteria. Exact criteria. What we are doing, initially current is here. Yeah. After that, current is moved. Current is moved to here. After that here, and then this is the exact similar case. After that, our current was pointing to null. But in this case, our current will point to 40. Our current to point to 40 because in first iteration we are getting three nodes. So I got these three nodes. And current is at its suitable position. So in the second iteration, what I got, current will move here, and move here, and then I will get these three nodes reversed. This is my second iteration, and now you can see after completing second iteration, my current is present at its perfect position. So that's why I am saying the current will be pointed on 70. So after that, when I saw that length value is lesser than k, so what I will do, what I am having 70 and 80, I am having this where current is pointing to this. So this is very easy. I have to put original tail dot next as current. So what it will do, it will create my whole linked list 30, 20, 10, 60, 50, 40, 70 and 80. Understood? So this will be our workflow. So I know we are having some heavy discussion, but let me write the code. This will clear your doubt. Your doubt. Okay. So our first function, which is add first node. Easy. Before creating that node, what we are requiring, let me move again. We require temporary head and temporary tail because these nodes are pointing to the starting and ending node of every temporary linked list which we are getting. Every sublinked list. This was our sublinked list. So every time we are getting temporary head and temporary tail pointing on these nodes. Okay. So what we will do? We will simply create temporary head and temporary tail. Easy. You will ask me why we are creating it globally, because these nodes will be accessed by this main function also and add first node function also. So to make it easy, I am creating it global. Okay. After that, what I have to do? I have to create add first node function, which will get some node to add. Okay. So what I am passing? I am passing the current node, and in this node we are checking whether that value of temporary head and temporary tail is null. If those value are null, so they will attach themselves on the node which I am providing. So I will check if temporary head is null. If it is null, then they will append themselves. They will put themselves on this current node. So temporary tail equals to current. And if this is not true, that means we are having temporary head and temporary tail are placed on some nodes. So in that case, current next should point to temporary head and temporary head should be placed on current. Okay, I have explained this, that's why I'm not going to explain it again. Okay, just rewind the video and you will see that I have explained this point. Okay, after that, I need length also, length of the linked list to make the total iterations. So int length, what this function will do, this function will return me the length. So len, let's rename this len and just pass the value of head. After that, we will create length which is equals to 0, list node just temp which is present at head. After that, while, this is a very easy function. Okay, I'm not going to explain you this function. If you don't know what I am doing, just watch how to find the length of a linked list. Okay, temp equals to temp next. After that, just increase the value of length. Easy. And just return length. Okay, very easy function. After that, we are going to start our main work here. Let me, yeah. Now, I want the current pointer which is traversing the linked list. So my first work is to create a current which is initially present at head. Easy. I have to find the length also. So length equals to len and just pass the head function, head node. Okay, I got this. Now I need original tail, original head also, which will point the starting and ending node of my linked list. So list node, original tail, which is initially null, list node, original head, which is also null. Okay, null ptr. Okay, easy. Now what I have to do? I have to create the main iterations loop. So while length is greater than equals to k, exact same as I said. Now what I have to do? I have to get the k nodes, So I have explained you how to get the k node. We created the for loop. If you know where we lost it, okay, we lost it, but we are creating a for loop to get k nodes. We have to traverse those nodes. So let me create a loop. I equals to 0, I is less than k, I plus plus. What this will do? This will traverse k nodes. Okay, we are traversing k node. Now we have to write the exact same code, which is to reverse it. What was the code? This node, this save equals to current dot next and exact same. So this will be your revision. Just recall with me what we have to do. A first point, list node, save, which will be current next. After that, what we have to do? We have to separate that node from every other node. After that, pass this node to the function. After that, just shift that current node to the next position. Okay, and what this will return? What this will return me? This is returning me this thing, 10, 20, 30. This will return me this thing. And what I have to do? If original head and original tail is null, then they will shift themselves. They will place themselves. So what I will check? If original head is null, which is initially. After that, else. If original head is null, so what I have to do? I have to place original head at the position of temporary head, original tail at the position of temporary tail. So original head equals to temporary head, original tail equals to temporary tail. Easy. If this is not true, if this is not null, so what I have to do? Original tail should point to temporary head. Original tail dot next should be equals to temporary head. And after that, just shift the position of original tail. Easy. Exact same code which I was said. Oh, exact same code. After that, I have to reduce the value of length. And we have to make temporary head and temporary tail null. Okay, I said na before first and second iteration, just make them null so that they should not point the same nodes. Okay, so I made them null. After that, I will check if current is not equals to null. That means current is pointing to some node. In this case, current is pointing 70. And let's say if I have 90 also, then this will also this will also reversed, and our current will point on null as we seen. Understood? In this case, our current was null. Here current is null. So we are having two cases. If current is null, that means we have traversed the whole linked list. And if current is not null, that means we left with some pointers. So original tail dot next should be equals to current. After that, simply return original head. Easy. Okay. So let me run the code and see if there any compilation error. No. And one more thing before submitting the code, let me write one more thing. basically we have to check the base condition also. What you will do if head is null. So some base conditions, let's say if head is null, this is base condition, or head next is null, that means we are having only one node. This is also what you will reverse if you are having only one node. And exact same case, which is if k is less than equals to 1. I will explain you. Let's say the value of k is 2. You are having this linked list 10, 20 and 30. Value of k is 1. So you have to reverse 10, you have to reverse 20, you have to reverse 30. So you will get the same linked list. So these are some base cases which we have to handle. Okay. Let's submit the code. We have run it. Let's submit it. Now this code will be submitted. Okay. So I hope you guys understood what we are doing. Basically we get the subpart, then we reversed it, and then we joined the next subpart with that subpart. Understood? So I hope you guys understood. This question is little bit tricky, and this question is very famous also. So you should know this by your heart. Understood? So we will meet in the next video. Until then, bye.